Hey YouTube, welcome back to the SoftBoarders. Today we're going to be solving the problem of reverse a linked list. A linked list is basically a node which has a value and a next. So given an example of a reverse linked list, we're going to be given the head. The head is the first element. So the head is just the node 1, which is going to have a next, which is another node 2, and it's going to have a next node 3. And they also have the value property, and that's the integer that's in them. So in the reverse linked list problem, it's very self-explanatory. All you need to do is just reverse the list. So in our solution, we're going to tackle this in one pass. So if we look at the problem, we are given 1, 2, 3, and one's null. An approach you're going to get very familiar with the more you do linked list problems is using pointers. For this problem, we're going to have 2 pointers. One pointer being the previous, because we need to reverse it, and one is going to be the current. We're also going to need a temp variable, and you're going to see the use for that in a bit. So for now, the temp is pointing to nothing. So in the beginning, we want to set the previous to null. This is because in the final output, you'll notice that the next of 1 is going to point to null. Right now, there's no null behind it. So we're going to create a null right behind it. And we want to set the current to point to the 1. So the algorithm we're going to follow is pretty simple. We want to check to see if the current is null. In the base case, if the current is null, we're going to return the previous. I'll just explain that in a bit. So right now, we check to see if current is null. It's not, it's 1. So if the current is 1, we want to set the temp variable to be equal to the next of current. This is because once we're switching the positions, we need something to keep reference of the next of current. You'll notice that because when we do this, we want to set, after we set the temp to the next, we want to change the next of the current, this pointer right here, to point to the previous. And if we don't have a temp, we're going to lose reference to the node 2 right there. So after we do that, we want to move the previous to current. So we're going to change the previous to be current, and we're going to set current to be the second node. And then we repeat the same thing over and over again. So we check to see if 2 is null, is 2 null? No. Then we set the temp to be the next of 2, which is 3. The temp is 3. And then we set the next of current to be equal to the previous. And previous now is pointing to 1. So this is just going to point back to here. We can clearly see this is reversing it in this order that we want it to. And then we do the same thing. We move previous becomes 2, current moves up to temp, where temp is. So current is 3. Then we check to do the same thing. Is 3 null? No, it isn't. So we set the temp to be the next of current, which is null. We set the next of current to be equal to previous. And then we set the previous to equal to 3. We move up the current to temp. Now, in this iteration, we'll clearly see that current is equal to null. If current is equal to null, what do we return? In this example, we have 1, 2, 3, and then null. And we can clearly see we return 3, 2, 1, null. So if we return the part that's pointing to 3, we basically have the desired output. And in our example, we can see that previous is clearly pointing to 3. So if we return previous, we will basically get 3, 2, 1, and the null we initialize in the beginning for the previous, the 1 points to it and to the null. And that achieves the output that's desired. So if we talk about runtime, as we can clearly see, we did all of this in just one pass, as we went through the linked list just one time. So if there are n elements in the linked list, that means the runtime is O of n. So for space-time complexity, let's fill it in. We never actually had to store anything except for create 3 variables. Each variable was just pointing to at most one item at a time. So we had the previous, we had the current, and we had the temp variable. They're basically O of 1 time each. So it's O of 3, which is just a constant, so the spacetime of the solution is just O of 1. Thank you for watching. Tune in next time.